Let's start recording. Okay, so today's the start of nuclear physics, and hopefully it's more of a recap lesson than anything else. It is. Do you want me to open it for you?
Yeah.
Yeah. Have you got it stuck?
No.
Can't open it. There you go, angel face. So, apologies for that. So it's going to be hopefully 99% of this will be straightforward and it molds into chemistry that we've been doing as well. It's all about atoms, but it's the start of really nuclear physics. Okay, so the things we're going to look at is the atom, the structure of the atom, and I looked within chemistry at the Avogadro constant, and it's not more, GCSE physics, you don't do any calculations with Avogadro's constant. You do it at A level, but not at GCSE. But it's more of an idea of how big atoms are, or I should actually be, descriptively more accurate, like how small they are, and then what their structure is, which you know, but we're going to go through it again. All right, so there is this what is an atom and everything makes up atom stuff, but I'm going to start off with a teacher stroke daddy joke. Why can you not trust atoms? Because they make up everything. I love that. All right. All right, I'll stop. Right, everything around us is made of atoms. All right, they're so small we can't see them, but that to me is okay. You know, if I really turn around and say, look, really small dust particles, you can't see them. All right, so this is standard form. You may not have done standard form yet in GCSE maths, but it's a way of writing a very small number. And the way that I look at it is 0.0. I want to write 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. So that's how small it is. It is diddy, right? So 100 million can fit across your thumbnail, right? Now, they are ridiculously small, but they have a defined structure that we know about, and hopefully this is, as I said, a recap. They have a nucleus in the center. It contains a proton with a positive charge, contains neutrons with no charge, and holds the mass. Nearly every single, all the mass of the atom is in the nucleus. Now, electrons are negatively charged. They're very, very small. Off the top of my head, I think it's 1,896 times smaller than that's off the top of my head, and I may forget. And they whiz around the outside. Okay. They occupy most of the space, which is weird. They make up the least amount of mass, yet they occupy most of the space. Okay. Now, here's the mass and the charge. This is a nice little table. You find a proton in the nucleus as a relative mass of 1. Neutron, same thing, same size. It's in the nucleus, but no charge. Electron -1, very diddy, about 2,000 times smaller. You find it around the nucleus. Right? Now, in an atom, now be very careful. I'm not talking about Cl- chloride ions or sodium ions or iron. I'm not talking about ions at all. I am talking about atoms. They have equal numbers of protons and electrons, and overall they have no charge. And I like to use the word neutral. Doesn't mean you have to use the word neutral. I expect, so I would write if I wrote an exam question about I would write something like, explain why the overall charge of an atom is neutral. And I would use that term neutral. But if you turned around and in your answer to a different question, you said, look, the number of protons are equal to the number of electrons, so there's no overall charge, or there's no charge, I will still give you the mark. You don't have to use this word, but we will. All right? Now, quick interesting facts. The nucleus is about 10,000 times smaller than the atom. All right, now if this is the nucleus in the center, you've got your electrons on the outside. If an atom was the size of Old Trafford Football Stadium, then, so if the atom was the size of Old Trafford Football Stadium, then the nucleus would be a P in the center of the pitch. All right. Now, because of that, an atom is almost empty space. Almost mostly empty space. That's almost empty space. It's mostly empty space. All right. Electrons in higher energy levels, and it's like when we drew them in chemistry, when we did the 288 rule a long time ago in chemistry. I think we did that. Your year 11, 9, so we did it probably in year 10. So these are energy levels. And the higher your energy level, the further from the nucleus. Right? If the nucleus, okay, so if the nucleus was the size of a marble, so if you imagine that size of a marble, it's like this big, the first electron is over 100 meters away. So there's a very, very dense nucleus, and there's massive space than your first electron. Okay. And so keywords: atom, smallest part of an element; nucleus, the central core containing protons and neutrons; a proton, positive large part, positively charged particle; neutron, this is a neutral particle, no charge in the nucleus; an electron, negatively charged particle going whiz, whiz, whiz. Energy level or shell is a path or a region where electrons are found. That's really important. So everything else is chemistry. That is a bit more physicsy. Okay, so you got like 10 easy, 10 medium, and 10 hard questions. All right. Now, I did drop in a little image. So I haven't added too much on because I don't want to jump into the next lesson, which will be something called isotopes. All right. So hopefully this is a recap for everybody who was late. I'm going to